Okay, me too.
All right.
Okay, let's go.
Hello, everyone. Welcome to the Robofest Online World Championship RoboMed competition where biomedical devices and projects using robotics are presented. Thank you so much for joining us today. My name is Elmer Santos. I am the Assistant Director of Robofest. Also with us today are Dr. CJ Chung, Director and Founder of Robofest, Shannon Polonis, Robofest Coordinator, and Daniel Oliver, who will be serving as our timer today. Thank you all teams for checking in. A note to spectators, welcome spectators. Spectators will be joining us via Zoom and also Facebook Live. The benefits of joining by Zoom are you have access to a webinar Q&A function where you can ask questions, and the quality is also better. If you've joined via Facebook Live, you can switch to Zoom using a link that's in the Facebook post. Any questions can be asked to teams using the webinar Q&A function. The questions must include the team ID and number, which can be found in the team thumbnail. At the end of today's competition, Q&A questions will be summarized by the Robofest staff and submitted to the teams by email. Teams will answer, and then the judges will use the answers for their final consideration. Robofest is a program of Lawrence Technological University. We would also like to thank our many sponsors. Thank you so much for supporting Robofest. Without your support, this event would not be possible. RoboMed is part of the Robofest Online World Championship, which is a series of events. It's the third event, and we also have some other events coming up in the next few weeks, so please join us for those. This is our program today for RoboMed. We're currently doing the opening, gonna have some opening remarks, introduction of judges, some announcements, and then we will go into the team presentations. Teams will present sequentially, and then we'll close up shortly after 10 o'clock. We have 10 wonderful teams today. This is the team list and the order that they will be presenting. Now it's time for the introductory remarks.
Greetings, friends of Lawrence Technological University all over the world. We welcome you to the first ever RoboFest 2020 Online World Championship, the only robotic competition in the world this year. I am Virendra Modgil, President and CEO of Lawrence Technological University in Michigan, USA. As you know, RoboFest is all about STEM, science, technology, engineering, and mathematics learning. Success at RoboFest requires mastery of multiple STEM and computer science subjects, which in turn drives preparation for college classes and high-tech careers. Additionally, RoboFest teaches students to develop soft skills such as problem solving, teamwork, creativity, and communication. This year marks our 21st RoboFest season. 2020 will be unforgettable. Due to the coronavirus situation, all the qualifying and regional competition around the world were abruptly halted in early March. However, we did not want to halt the learning opportunity for students. LTU's RoboFest created new modality in the competition-based learning environment to cope with the unpredictable future rather than canceling it. So thank you for your participation in this new, unique, and different format of competition. I commend all of the teams and students here for being active learners and pioneers who are eager to master technologies for the future. As you may know, Lawrence Technological University was founded in 1932 with the support of the auto pioneer Henry Ford. At that time, Ford's famous Model T factory was at the forefront of an industrial revolution that changed the world. Likewise, we are at such a forefront of new technologies today. LTU and Robofest are paving the way. Someday, I hope you will join us here at Lawrence Tech to continue to do the excellent work you are already doing with LTU's Robofest. Your efforts are advancing science and technology for solving real-world problems. At this time, I would like to thank all the teachers, coaches, mentors, and parents. You make this program possible for our students. Without you, teams do not exist. Additionally, I would like to thank all of the inspirational international directors who have organized local qualifying competitions or are sending teams to Robofest 2020 Online Championship. Finally, we cannot give enough thanks to Robofest's local judges and LTU judges for their dedication and volunteerism. Let us give all of them a round of applause. In closing, I wish all of you luck with your endeavors today and hope you have a great connected learning and collaboration experience through this unprecedented online Robofest 2020 competition.
Okay, next we have the introduction of judges. Each judge's short bio is available on our World Championship homepage. Okay, for our esteemed judge panel of judges today, the first judge we have is Dr. Therese Bouakoul.
Good morning, everyone. So my name is Therese Bouakoul, and I have an MD degree and PhD degree in biomedical engineering. And currently I hold the position of the research lab manager at Ascension Providence Hospital, Southfield, close to Lawrence Tech. And I've been in this position for 4 years, and we do mainly research related to bone and tissue engineering, clinical and basic science research.
Thank you very much. Thank you so much for being with us. Next, we have Dr. Hao Jiang.
Oh, good morning, everyone. My name is Hao Jiang. I'm an assistant professor in Department of Biomedical Engineering at Lawrence Tech. I'm kind of pretty new here. I just joined here for 1 year, and this is the first year I participated in Robofest. Before that, I just want to say the same thing I told everyone. After I watched all the videos you guys presented, I just want to say, like, when I was in your age, I really wish I could do something that is so cool as you are doing now. So I wish you all good luck in today's competition, and thank you for participating.
Thank you. Next, we have Dr. Alexandra Kuzmanov.
Hello, everyone. My name is Alexandra Kuzmanov. I'm assistant professor of biology here at LTU. So before I became an educator, I actually used to practice medicine. That was some 15 years ago. This is my first time judging the Robofest. Very excited to be here. And I would like to wish you all good luck. Thank you.
Thank you. And our last judge is Dr. Yawen Lee.
Good morning, everybody. My name is Yawen Lee. I'm associate professor and also chair of the biomedical engineering department at Lawrence Tech. And very happy to have the opportunity of coming here and learning about your exciting biomedical projects using robots. Little background here, I'm also the parent of a Robofest team. We participated in previous years, the Robofest Auto Sumo and the games, and a lot of fun. And this year, one team of our teams also participated in the Unknown Mission Challenge. So look forward to your presentation today.
Thank you.
And Elmo, can you introduce code inspection judge who could not be here today?
Sure. Yeah, also, not here today, but a very important part of our judging panel was Mr. David Carberry, a engineer from Fanuc Robotics. He has done the coding inspection. I'll explain a little bit about that next. Okay, just a quick summary of how the judging will be done. Teams were required to provide a video and source code files previous to the competition. David Carberry, our code inspector, has reviewed your code and recommended points for programming. For today, each team will have 4 minutes to present, followed by a 2-minute question and answer period. Afterwards, judges may ask additional questions by email. And these questions will be coming to the teams by me, Elmer Santos, as the coordinator. And teams will have 24 hours to answer. And then note that for those of you that have competed in live competitions in previous years, the rubrics are slightly changed for this year. Okay, now it's time for the group photo. So would everyone please turn on their cameras so we can see you?
See. Okay, I'm ready to take the photo. Concordia, you coming on?
They have two
Everybody
cameras.
smile.
I'm gonna put Concordia
Looking
and
good.
two. Hold on one second.
Okay, hold
second,
it.
Sam.
Got to get the next page. All right, here we go. Okay, thank you, everybody. We are all set on our EcoMed photo, and I wish everybody the best of luck.
Yes, thank you. Thank you, everyone.
I don't know if they heard me.
Yeah, we heard you, Pam. Okay. I think we're ready to get into the formal part of the competition, the team presentation section. All right, Shannon, do you want to explain how that's going to work?
Sure. What I'm going to do is everybody except the first team presenting will be moved from the panelist view to the attendee view, so you can still see and hear everything, but you just won't be on the screen. The judges will remain on the gallery the entire time. The timer will also be on the gallery, so we can refer to it. We will spotlight different videos. If you have 2 videos, 2 camera views, we will bring both of those in. And then, so at this time, I'm going to move all of the teams except the Aerobots to the gallery, the attendee view, or out of the gallery into the attendee view. So then we'll bring you back in as your team is up to present. So enjoy the show, enjoy the presentations. We appreciate all of you being here. And let's finish up getting all these teams to the attendees. Let me help out a little. I'm gonna go start at the bottom. So Aerobots, you're up in just a moment. The Aerobots are not here. Where'd they go? Did they disappear? Where'd they go? There they are. Okay, so I'm going to turn off my video. So I'm not in the gallery.
Good morning, everyone.
Good morning. As soon as you're ready to go, hold on. As soon as you're ready to start, we'll start the timer. So we're going to spotlight you as well as spotlight the timer so we can all see.
Okay, we prepare a PowerPoint presentation. We want
Okay.
to start the screen sharing.
Yep, we can,
Oh, we can see it.
Yes. Can you see the presentation?
Yes.
Okay. Please tell us when we can start.
You can start now.
Good morning. We are the adults team. Hey, Antonio, and he's David. We have the ID to 2895-1, and we are going to present baby breathing.
Every year in Mexico, 2 million babies are born, from which 200,000 will be premature. This means they will require specialized treatments such as oxygen therapy. Oxygen therapy, in simple words, consists in supplying a specific quantity of oxygen to the baby until he can breathe by himself. Unfortunately, this treatment is not always effective due to the following factors. Oxygen quantity supply is estimated and not always is regulated on time because it's manually adjusted. In addition, work overload of medical staff makes it difficult to have a continuous monitoring of patients, besides the fact that babies' response to treatment is unpredictable. At the end, an ineffective treatment can lead to visual, cognitive, auditive, and respiratory disorders. And now, how we broke this circle? Real-time oxygen regulation supplies the exact quantity of oxygen that baby needs. With continued monitoring during the whole treatment, we help medical staff react in time and indirectly reduce the amount of work for them. In addition, data recording gives medical staff data-driven diagnosis and help them develop a more accurate oxygen therapy protocol. So, next please. As we saw, real-time oxygen regulation is the most important feature. Before developing a solution, it's important to know the system. As input signals, we have the following. However, the oxygen saturation is the most important to supervise. For output signals, we need to control the oxygen flow. And finally, it's important to know the working limits and its critical conditions to define the system boundaries. Our development is divided in 3 phases. First, we started with the design of the mechanical actuator for the flux meter control. Second, for software and control design, we made an oximeter to understand how it works, and the signals involved to control the step motor. And finally, we run simulations to test both models working together. And all of this led us to first prototype testing. However, to have a real behavior of our device, we need a patient that has an oxygen saturation below 80%. That's why we present this simulation. In this case, you can see a baby that is in critical condition. You can see your oxygen saturation starting below 80%, the green line. And it controls the white line, that is the oxygen supply. And depending on the oxygen saturation levels, the oxygen supply will be increasing or decreasing, depending on the working limits or in cases of critical conditions.
At the end, we have a better and a correct treatment, savings for the family and the hospital due to reduction in hospitalization time and resources needed. And finally, with the data collected by our device, doctors will have more tools to give more accurate diagnosis. Now, some numbers. The first prototype has a cost of $560 being the main real controller the lead cost. It's important to consider that the cost calculated is only for one device with one input signal enabled. Final cost of the device will be defined after design freeze, manufacturing method, and volume forecasts are defined. Finally, let's talk about business. We are using Canvas tool as our first approach for our business model to identify key activities and stakeholders. It's important to highlight that Hospital General de Atlacomulco in Mexico State is our first potential customer, and as the pilot program supervisor, we have Dr. Girol Regorreta, who has been supervising the medical research during the development. For this, we are looking for capital to continue with the development, start with preclinical testings and patent process. Thanks. And for detailed information, check our website.
Okay, thank you. Okay, I think it's time for the question and answer period. Does someone want to start with the questions?
Okay, a quick question here. Great presentation. Did you do the test on real, like human subjects, or you just simulate? Is there a plan of doing this on real human subjects?
I will tell them because they didn't hear you well. She's asking if you make the real testing on real person, or did you use another method?
To understand how it works, the oximeter, to acquire the signals, we started creating our oximeter basing of the functional of a real oximeter. After having that, we put our device can work in two ways: by simulations, putting the cases of belowing the oxygen saturation below 80% or operating, or with the real cases with the data acquired by our oximeter.
Okay, another question. Safety is very important because of babies' lungs are much weaker. How does your team propose to control the gas pressure applied to a baby?
The gas pressure, the oxygen flow. We control it by using a step motor, and depending of the number of steps that we send it to the motor, we can control the oxygen flow. We are thinking to put an oxygen flow sensor to have a more accurate control of this.
Okay, are there other questions from the panel?
Yes, I have one question. Considerably with when we use oxygen in babies, we put them in something like cages. So I'm not sure if they took into consideration how the oxygen is applied to the baby. Is it through a mask or they are in these boxes? What's their vision of that?
I didn't hear it. Hello.
She's asking how the oxygen is applied, because there are incubators where they put like the free flow, or is it going to be through a medical mask directly to the face of the baby?
Depending on the device that you will provide the oxygen through the treatment. We are started using the mask, but we know that the treatment can be supplied using the mask and neonatal shield, or using the free flow of oxygen. And depending on it, we can use it. We are thinking to put that the device will work just putting the oxygen supplying, and after the device putting in at all place of the device.
Okay, very good. Thank you very much. Unfortunately, time is up. Thank you very much. We're going to have to go to our second.
For pleasure.
So thank you. Okay, our next team is going to be Ternary Shot from Saudi Arabia.
Yes, hello.
Hello.
Hello, everyone. Can I start?
Yeah, is the timer ready?
Okay.
Yeah, go ahead and start whenever you're ready.
Okay. Hello, everyone. I'm Dina, and I'm here to represent my team. We're 3 electrical female engineers. We are from Saudi Arabia, King Abdulaziz University, and our project is wireless charger circuit design for a pacemaker. So let's start with a brief introduction about the pacemaker. It's a small but very sophisticated electronic device that implanted under the chest. It's used to treat arrhythmia when the heart beats too fast or too slow. So the problem is whenever the pacemaker battery expires, the patient have to replace the whole pacemaker unit itself. So most of the pacemaker batteries only last for 4 to 10 years. The statistic shows that 5% of people or patients having issues after the replacing surgery, and 50% of them require a replacement procedure. So 11 and 60% of them need multiple replacement, and we are making their life at risk. So our smart objectives are to devise a working prototype that wirelessly charge the battery of the pacemaker. So second, the recharging visit to be once a year, taking at most 3 hours to be a fully charged, the battery to be charged under the supervision by a hospital technicians, and also it can be shifted to a robotic thing. The separation between the transmitter and the receiver to be charged, the optimum situation is 1 centimeter, and the transmitted frequency not to harm the human being, and to be in the allowed frequency that the human can transmit and receive. Okay, so the block diagram of our system consists of 3 parts: the transmission, the resonant inductive coupling, and the receiver. We started by simulating and testing our design on a Protus. We designed the transmitter, the coils, and the receiver, and we added a voltage regulator as a voltage level indicator to see the charging process. We test each part separately: the transmitter connecting with the function generator and the coil, the receiver, and the voltage indicator. We used an Arduino to just represent the charging process. So this is our final product, a transmitter connected with the function generator that provide the voltage to the system and the safe frequency, connected with the receiver. Then we added a voltage regulator just to make sure that our product is charging with a suitable time. So the test and result shows that the amount of time that takes to be a fully charged and charging the pacemaker battery is only 40 minutes to be fully charged with 3.7 volts. So our future development are the charging process to be with the heartbeat, and then taking the project into the next level, which is a monolithic technology. Test this project into an animal, evaluate and making sure that taking into account the bone tissues and heat that can affect the human, and also designing our own battery. I will just represent a video from our work.
Is there supposed to be sound?
No.
No, okay. Just checking.
Okay, I just finished. Okay, thank you.
Okay, thank you very much. All right, do we have questions from the panel?
Yes.
I have one question. Did they notice any changes in the heart rate when they did the testing, when they were charging the battery?
Excuse me again?
Did you notice any changes in the heart rate when you were doing the charging?
No, we couldn't, because we just implanted, we did not test it on an animal or something that related to the human yet.
Okay, how is charging affected by the relative positions of the transmitter and receiver?
It should be one-to-one. It should be directed the core into the core, and we used a ferrite core to these two coils, that the transmission not going anywhere, just to be directed to the another directly to the another receiver coil.
Is there any kind of feedback to indicate that the charging is working?
Yeah, we added a voltage Arduino that with LCD to represent the charging process, a percentage.
Okay, thank you. Okay, are there other questions? Go ahead.
Oh, hey, very nice work. So because I'm teaching about pacemakers in my medical device design in the class. So as we know, like very often patients pacemaker, you want to make sure to avoid any possible electromagnetic interference to it. So then now you are connecting this one wirelessly to another device to charge it. So how do you comment on the safety issues? So what if the device gets disturbed by other interference? How could you do that?
We can just making the charging process in an isolated place that only can a human, the doctor or the robotic thing, and the patient only be that in the same time during that charging process, isolated place.
Okay, thank you.
Okay, we're out of time, unfortunately, but thank you very much for your presentation.
Thank you so much. You're welcome.
Okay, next up, we are going to start with the senior division. Yep, first team up for the senior division will be team 2647 Zip Ties.
Hello.
Hello. Okay, I think the timer's ready. Go ahead and start when you are ready.
Okay. So wait, let me just a sec. Can you see my screen?
Yes.
Okay, awesome. So hello, my name is Kirillo, and I would like to present to you my concept of a lung ventilator. So you've probably seen this big one. So it's used for patients who need assistance with breathing due to COVID-19, lung cancer, or asthma. So basically it provides air in and out of the lungs. But because they're really expensive, US lacks about 200,000 of them. So many doctors use these airbags called manual ambu bags. So basically how they work is you squeeze them and they give air. And my design is based on the automation of this bag. And so why did I decide to do that? Because doctors use both arms to pump this bag, as well as they have to count in their head how often they have to pump it. And doctors are really mobile and they have to focus on one task. So my project simplifies doctors' life basically. So it allows them to do something else while patient is getting air. So my goal was to make a light portable device that would give patients air. So that's my final design. I will just a sec, stop screen sharing. Here, it's a really small box. It's real portable. Doctors can take it anywhere. And so it has two servo motors here and there. And basically they compress the bag from both sides. And it also has a button and a toggle switch. So you turn it on with a toggle switch and you change the speed with a button. So in order to turn it on, you need to connect this on pretty much mask. That's how patients get air. So you connect it on here, you turn it on. And so as you can see now, I'm getting air. Also, you can control the speed on the screen. You just hold the button and you'll change the speed basically. So all the appropriate speed is on the manual. This device I wrote the manual with doctors from the university. So all patients, according to weight and age, have their own appropriate air volume served. So I have iterated through actually several designs, but this one has proven to give the best compression and the best overall results. And it's really small also, as I said before. So my circuit is really simple. It has a main Arduino controller. It has a small motor driver. So Arduino controls everything except motors. So motor driver is responsible for to control the motors. So you might see that I'm using only one resistor, which is really uncommon. I don't use resistors for button. It's because Arduino is really convenient and it provides 20K pull resistor on some of the pins. So that's a pretty uncommon thing, not to use a resistor with a button. I just, according to Ohm's law, 20K pull resistor is okay with the button that I have. So my code is simple. It's based on the idea of task scheduler. It's kind of how in a queue in a store, one person is after the other. So I have one task after the other. So one of the tasks is to show the number of the speed, to check if the button is pressed, and to move the motors. So finally, how would I sell it? So this device is ready to be sold. It was tested by doctors. And so it would not be sold in ordinary pharmacies because it's a device for doctors. It needs training, some kind of. So it could be sold directly to hospitals of 40 or more units. It could be sold not only during COVID, because patients before COVID and after COVID will need this ventilator, and it's priced about $45. And you can see specification of small spec sheet down at the bottom. Thank you.
All right, thank you very much. Okay, now it's time for questions and answers.
I do have one question. Great job. It's really great. Remind me how at the time when I used to do Ambu back for hours and hours. So it's great. But did you consider doing your pieces of the equipment movable? So if you want to use pediatric Ambu back, because they are usually smaller. So are these?
Yes. So as you can see here, you will have to. I have actually on my website. I have a few options. So for the pediatric one, you just need another box because as you can see here, it has special holes, so it's stable, so it doesn't move. You just need another box, which would have actually holes just like a bit below, and it would fit the smaller airbag.
Great.
How long will the AA batteries last in powering the servos in continuous motion?
I have tested. So talking about servos, they last for 6 hours. Oh, no, for 16. I have it. Yeah, 16 hours straight. I tested it. I'm going to be honest with you, I didn't test the batteries. I've been using it for over 35 hours of time. And it's been okay.
Okay, thank you. Yes.
Okay, quick question here. Yeah, very interesting design. So this, from what I see, is a medical device. So is there any regulation you have to consider before selling it?
Yes. So as I said before, I have a manual here. It's a 2-page manual where at first it has says who can use this bag. You need a special certificate to use it. And also it has how to check before use. So you have to test it before you use. And it also has how to use. And yeah, that's why I don't want to sell it to ordinary pharmacies because not all people are allowed to use this device.
You may need to look further into the FDA regulation. Any medical device has to be regulated. And so that's additional.
Yeah. I considered it because I live in Ukraine now. I mean, I live both in US and Ukraine.
Mm-hmm. Okay.
I'm in Ukraine. So in Ukraine, there are actually no official regulations, unfortunately, because it's obviously not I have talked with the doctors and they say that's one of the big problems with our health system, that we actually don't have like really strict regulations.
Okay, our time is up, unfortunately.
Okay,
but thank you very much. Wonderful project.
Mm-hmm.
Okay, next up, we have team 2648.
Should we just share our screen and present?
Yeah, just go ahead, share your screen, and then start whenever you're ready.
Okay, cool. We can start. We'll start. Hello, this is Team Wally from Cranbrook Schools in Michigan, and we'll be presenting our robot Relax Bots. We spent 3 weeks on this project during our self-quarantine, and although we both worked on building the robots, I focused more on machine learning and Scratch, while Sarah worked on the Arduino code. Yep, and a forward on stress. Actually, chronic stress has been shown to be increasing. You can look at the graphs on the right, and it's been rising over many years steadily, but we propose a few ways to deal with it with our Relax Bot. We designed the robot to help those who go through stress in their daily lives, and our robot measures user stress levels by incorporating a heart monitoring technology, and it'll give different responses to the patient according to their heart rate. Yep, and it has a lot of functions, including, so movement will be a big part of the Relax Bot because it needs to successfully approach the patient's call. Yep, and it's going to use a distance sensor to stop at the appropriate interval to the patient. We use machine learning, which is a platform that allows us to record and train recognizing specific words. And we use a heart monitor, which we solder to the breadboard to actually read the patient's heart rate and display it on the Arduino software port monitor. So we combined machine learning with EB3 to enable the robot to give different responses to the patients according to their different heart rates. Yep, and we actually are targeting, planning to make RelaxBot a product and selling it to different hospitals, care centers, households even, with people or patients with anxiety disorders or something like that. We think the demand is going to be high because it's going to be increasing as the stress levels are increasing in the population. It is convenient and it is also aesthetic because of its cute design. To enable the robot to measure the distance and stop at a certain place, we use the ultrasonic sensor, which is attached to the EB3. Yep. And for the Arduino part, like I said, we soldered the heart monitor to a breadboard and connected it to the Arduino. And everything is going to be pretty much displayed on the serial monitor, and the patient can just read off their heart rate and tell it to the robot. So this is the code for the Arduino. It's just kind of declaring the variables here. The main thing is the heart rate monitor is just using LEDs to kind of differentiate between the oxygenated blood and the desoxygenated blood in the finger, and thereby measure the heart rate as well as oxygen levels. But we're focusing mainly on the heart rate. And then it will display them on the serial monitor so the patient can actually read it. So to facilitate auto detection, we taught the robot to recognize specific voice commands by repeatedly training an algorithm. And so first, when the robot will recognize high relax spots and then respond to the patients with their name. And after using the ultrasonic sensor, the robot will move towards the patient and stop at a distance less than 10. So we modified our code from last time to enable this. And we'll show you the demonstration right now. Yep. So I'm just gonna stop screen sharing and flip my camera. Okay. So it responds to the command, hi relax bot. And then it just moves towards the patient. So here.
Hello. Do you want to measure your heartbeat?
Yep. And you have to just press a button for it to respond to the command.
Please place your monitor.
Yeah, it kind of glitched out there, but it pretty much tells us to place the finger on the heart rate monitor. And if we do it, we can actually display it on the serial plotter over here. So if we go on the serial monitor and display it, it's going to read off the red and then the IR values, which are the red LED and the infrared LED. And then it's just going to read off our heart rate. So for example, it's asking for the heart rate. Oh, we could do 67, which is like a normal range. 67.
Okay, I'm sorry. I think the time is up.
Oh, okay.
Oh, but thank you very much.
Yeah. Okay. So it just pretty much responds with that, and yeah, so thank you.
Okay, now it's time for the question and answer period. Go ahead.
Just a quick question. So it's detecting a heart rate, but I was wondering if your device can detect irregular heart rate.
Yes. So if the heart rate is over 120, so it will beep and then give an instruction on how to deal with it. It'll like alert the bypassers, and that's our goal. Yeah, and it has like a serial plotter as well. We weren't able to show it, but it can display a graph of the heart rate actually, and it can show any abnormalities there. So it's very detailed.
Oh, nice. Thank you.
Yep.
Great presentation.
Thank you.
Okay, do we have another question? Yeah, where did you obtain this heart rate monitor and how did you learn how to use it?
Well, we were actually looking for the cheapest options on Amazon because building our own wasn't really an option because we did the whole project in quarantine while we were here in the United States. So we just ordered the heart rate monitor off of Amazon and we were looking just for the specific functions, but then we connected it to the Arduino and coded everything ourselves. Yeah, so we were mainly looking for functionality, yeah. I believe it was $8 or $7 on Amazon, so it was pretty cheap. Yeah.
All right, very good. Do we have other questions from the panel? No, what was the most difficult part of your project?
Well, I'd say probably the time constraint that we were under because we just arrived and then we really wanted to participate. So we were planning it before ahead of time, but then we had to kind of adapt to the time constraint and then come up with this like project. So I'd say working with that was quite difficult, but we did set a certain schedule and we worked on it for like 3 hours a day, I believe, from 10 to 1. So yeah, that was kind of like our main thing.
Okay, very good. Okay, unfortunately our time is up, but yes, that is the entrepreneurial constraint, time.
Yeah.
Yes, thank you very much.
Thank you.
Okay, all right, it's time for the next project. Okay, next up we have Ecotech Med.
There we go.
Make it full screen.
Okay, are they gonna screen share right now? The other team?
We're gonna see. Actually,
Wait, does the other, oh, there they are, okay. So let them know when you're ready and you may begin anytime, I think.
Yeah, you can begin when you're ready.
Hello, my name is Jonathan Bryant, and I'm the team leader of our group Ecotech Med, and today we are here to present our COVID-19 drone. This is an autonomous drone that utilizes viral agents to help detect COVID-19 in the air. The detection of the virus using this drone will help regulate safety in high-traffic areas such as communities of color, where the risk of contracting the virus is 2 times higher than in other areas of the United States. This is due to factors such as crowded living conditions, underlying health conditions within a large population of minority groups in America, and people working in essential fields.
Hi, my name is George Johnson, and I'm the lead virologist on Team Ecotech Med. My role today is to describe to you how the Q-tips are supposed to respond with a potential virus in the air. We're using a blueberry solution that's filled with anthocyanins. When the anthocyanins come into contact with something that is acidic with a pH level less than 7, you will detect the color change, and the color change will be a reddish color. And that's what we're looking for today because the pH level of the coronavirus is 6. And we are now sharing our screen to show you the code that we are using on this drone.
Hi, my name is Joshua Miller. I am the lead programmer of Ecotech Med, and here's our code. Our string is when key press to start the code. Our object is the drone, and anything afterwards is the function. And in the parentheses of each lies the value of each command, which means the direction or value of seconds.
Hi, my name is Omari Ishmael. I am the lead engineer for our Ecotech Med drone, and today I will be talking about the anatomy and the build of our drone. This is our drone. This is our drone. These are the parts of the drone. This is the motherboard, the propellers with the guard, the top frame, the bottom frame, and it has a couple built-in sensors. It has a gyroscope sensor, which helps keep the drone balanced, a IR height sensor, a barometer sensor, and a optical flow sensor for hovering. And this drone is programmable. And now I'm going to show you the demonstration of our drone.
as they're preparing to demonstrate the drone, the goal overall is to make a viral map to be able to predict the next hotspot of the coronavirus. When you are in an area that polluted, you can have decreased lung defenses and respiratory issues. And our goal is to predict where the next place will be, alerting hospitals on what their next move should be.
Okay, ready? See it?
Can you see the drone?
Yes.
Okay. It's gonna go back.
On the drone, there are these Q-tips with the blueberry solution, and we will be using that to indicate the color change of anything acidic in the air. Again, we're looking for a reddish tint to this color because the pH level of the coronavirus is 6.
Okay, we're gonna do the demonstration one more time. All right, ready?
And we have been broadcasting from Detroit, Michigan.
And this is Ecotech Med.
And we're starting.
Let's go.
So we had a little wind turbulence, so it was going all over the place kind of, but that was where it was supposed to go straight, come and come back.
We have been broadcasting from Detroit, Michigan, and this is Ecotech Med.
All right, thank you. Okay, it's time for Q&A. Go ahead.
Okay, thank you for your presentation. Great presentation. So I was wondering, you mentioned the audio wasn't clear at the beginning, but if I understood well, you want to use pH of the virus to detect it in the air, right? So I was wondering if your device can detect different concentrations of the virus in the area. So how do you plan to do that?
So we were using the color indication system. So for different strands of the virus, there will be different colors because there are different pH levels. It's just a matter of what color you're looking for. So in this case, we were looking for a slight red color. If we were looking for something with a pH level of 1, it would be a bright red.
Okay, thank you.
Go ahead.
Mute myself. Yeah, great presentation there, and kind of along the line of Dr. Kuzmanov's question here as well. I guess mainly regarding specificity of your device. So pH alone, I'm not quite sure if the pH is the only indicator to differentiating coronavirus versus the other type of virus. So it might be worthwhile looking into other additional markers or indicators there to show specifically that's the coronavirus versus some other type of pathogens there. But great demo there.
Can you repeat that one more time? The last part was unclear.
I'm saying maybe in the further development of your device, there might be worthwhile to consider additional markers, additional indicators you can add to your device to specifically say what you detect there is coronavirus versus some other type of virus.
So the overall goal of the project was to find polluted areas. So people in places like Detroit and Los Angeles and Chicago are in places that are more susceptible to air pollution versus places like North Dakota or any city in North Dakota or South Dakota. So when we use these Q-tips, and we also use the air quality tracker to detect the air quality index, but we're really looking for polluted places and hotspots in those areas because people in those areas are more likely to contract that virus.
Okay, I'm sorry, the time is up.
Okay.
All right, but thank you very much for your presentation. Okay, next up we have the Tech Sisters.
Hello? Can you hear us?
Yes, I don't know if we can see you though.
Oh, we're right here. Hello?
Okay, now we're good. Okay, go ahead and start when you're ready.
Hello, we are Team 2213-4, the Tech Sisters. My name is Janet Chaudhary. And my name is Pragya Chaudhary. COVID-19 has infected over 28 million people worldwide and continues to spread. However, public spaces have begun to reopen. Current protection methods, such as temperature screening and facial protection, can be ineffective. We, the Tech Sisters, have developed 3 innovations to help restart normal life safely. The first is to help improve temperature screening. One of the most prevalent symptoms of COVID-19 is fever. Currently, essential workers stand outside buildings and manually take the temperature of people entering. Not only is this process time-consuming, it is dangerous for the workers. To safely measure the temperature of people entering public places, we have built a body temperature screener. It uses a PIR sensor to detect human presence and a thermal imaging camera to measure the temperature. This mug filled with room temperature water signifies someone with a normal body temperature. This mug with hot water represents someone with a fever. When someone with a normal body temperature comes before the screener, it will allow them to enter the building. When someone with a fever comes before the screener, the PIR sensor will detect movement, the thermal imaging camera will take a thermal scan, and will alert them to return home and seek medical attention.
You have a high body temperature. Please go home and consult a doctor.
We used Python to program this on a Raspberry Pi. One thread is running to gather data from the temperature sensor. Another thread is running to draw the frame based on the thermal imaging camera readings. And a third thread is running to control the door using a stepper motor based on readings from the PIR sensor and the thermal imaging camera. We plan to market this to public spaces such as schools, stores, and airports. The next innovation is to help improve facial protection. According to the CDC, COVID-19 primarily spreads via respiratory droplets. One of the recommended methods of protection is wearing a face mask. However, due to issues like face masks being worn incorrectly or not being washed regularly, they aren't providing the optimal protection. Moreover, they obscure the face, posing a security risk, especially in schools. One alternative is wearing a face shield, which allows for full view of the face. However, they don't provide adequate protection as the droplets can spread out and enter through the open sides of the visor. This is why we have built the protection helmet. The helmet has a fan at the top to create positive air pressure. This will only allow filtered air to come in through the top while not allowing any unfiltered air to be breathed in. The helmet also acts as a social distancing monitor with ultrasonic sensors at the front and back to measure distance. If someone steps within 2 meters, a red LED will go signaling the user to step away. We programmed this on a particle photon using the C language. Due to the volatility of the ultrasonic sensor, instead of taking one sensor reading, we took a sample of distances and calculated the first quartile value. Based on this value, we controlled the relay, which in turn controlled the fan. We also powered the LED. Our third and final innovation is a simple, inexpensive, non-invasive ventilator in order to make ventilators more accessible. First, the inhalation cylinder will draw in fresh air and then provide it to the patient. Then, the exhalation cylinder will extract the exhaled air and push it through hot water kept at about 56 degrees centigrade to disinfect. The water temperature is being monitored by a temperature probe. If the water temperature drops below 56 degrees, it will alert the user to heat up the water to ensure proper disinfection. We are constantly monitoring the water temperature using a small window so that they can monitor what temperature it's at.
The water temperature is too low. To ensure proper decontamination, Please heat the water.
This system uses two programs, one to drive the pistons and one to monitor the water temperature. The program to drive the pistons controls a servo motor to a servo driver based on values calculated from a data sheet. To adjust the pumping rate, you can adjust the value of the delay variable. The program to monitor the water temperature, has two threads running, one to measure the temperature and speak to notify if the temperature is too low, and another thread to create a frame to display the temperature. This ventilator design is open source and build instructions can be found on our website. Scientists have predicted that pandemics will be more prevalent than.
Okay, I'm sorry, but the time is up.
Thank you for listening. Any questions?
Okay, you go first. Oh, I go first, I guess. I'm yeah, this is great. I think I'm really impressed. How much time did you spend on this project?
We've been working on this project all summer long. We put a lot of hard work into it. Yeah, we had first kind of presented like a preview of this project in the the practice Robofest, and then from then we've been working on it.
Okay, yeah, very impressive. I just say great job.
Thank you.
Presentation as well.
Yeah, great job. I was wondering about your helmet. So it was you had a lot there, so you presented really fast. Could you please explain to me how this exactly works?
So here, we'll bring the camera closer. So first, so basically there is a fan at the top that we've covered with a filter. Currently, it's just
there is a filter. Okay.
Yeah, and so this creates positive air pressure. So whenever you come too close to someone, which is measured by the ultrasonic sensor, it has a relay to run the fan, which will create a positive air pressure, which will not allow any air to come in through the open sides of the visor.
So the air is going up through the filter. Okay.
Yeah. The air is coming down through the filter. Our main problem was with the visor that it was coming in through open areas. So with the positive pressure, it is only allowing air to come this way, not allowing any air to come in this way.
Okay, perfect. Thank you.
Thank you.
Great job.
Thank you.
I have one question for the doors and going in. Did you take into consideration that there are going to be small kids and adults going into the school?
One of our future
what about?
One of our future enhancements for this is to use facial detection so that it will take accurate measurements of people's faces and to take accurate temperatures.
Okay, have you taken any precautions regarding the high water temperature of the ventilator?
For the high water temperature of the ventilator, it'll be in an insulated, better condition, a better container, insulated, and we are constantly monitoring the temperature using a temperature probe.
Okay, I'm sorry, time is up.
Okay.
But thank you very much.
Thank you for listening.
Okay, next up we have Smart Labs, RoboMed.
Okay, I think we're all set.
Okay, yeah, go ahead and start when you're ready.
Hey, hang on. All right, sorry.
Yep, take your time.
Just getting set up.
Yeah, no rush.
You guys ready? All right. Okay, we're good.
Yep, go ahead.
Hi, we're Smart Labs. I'm Maria. And I'm Shreya. We've been doing robotics together since 4th grade. We're here to present our concept, RoboMed. We'd like to thank our sponsors, the Michigan Council for Women in Technology and Robofest for the use of the robot and camera. Millions of patients and elderly suffer poor quality of life due to lack of mobility where they live and difficulty in going to a doctor. Disease staff suffer from disease exposure, including COVID-19, and waste time traveling to patients.
In February this year, I had some abdominal pain, so I went to my doctor. He said he couldn't treat me, so he sent me straight to the ER. After 4 hours of waiting and only a 10-minute ultrasound, he said I was just fine. The bill was $7,000 for only 10 minutes of work. I was resolved to find something with RoboMed. The robot represents the bed or the gurney or wheelchair that will be used to transport the patient. The demo area represents the hospital, and each room in the hospital is designated by a different color. The wireless keyboard represents remote operation. RoboMed consists of an open CD camera, a mobility system, a robotic arm, and connection to the cloud.
By providing mobility and remote interaction, the bed can solve problems in hospitals, doctors' offices, elderly care facilities, and patients' homes.
Oh no, we have a patient with a burst appendix. We need to go to the operating room.
Sorry, we need to deal with this now. We're switching to the front camera and starting the scan. We're scanning the rooms to create an internal map.
Look at the top of the image. This shows how we process the images. We convert to grayscale, blur, detect contours, and detect the different circles in the image to detect which rooms are there.
We determine the room based on the color. We know the angle based on the screen coordinates and calculate the distance based on the circle size. Notice when Maria moves the board that the position and angles are getting automatically updated. We use QR codes. We use QR codes to tell the robot which room to go. I'll confirm the operating room decision. The bed uses the map to turn to the room, then corrects the angle based on the camera. We send commands to detect, click, and drive. Self-driving automatically isolates patients and prevents transmissions of diseases like COVID-19.
We send commands to the 6 servos to perform this operation. It will have a camera connected and it will change tools for every job. Think of what we can do with the arm when we combine it with haptic feedback to measure force and remote operation. A doctor can perform 100% of a physical without the patient going to the doctor and without exposing either the doctor or the patient. There are 1.1 million US doctors. The average doctor's visit is only 5.2 minutes long. We can learn from every doctor's visit and also from collecting data 24/7. RoboMed is a platform for medical innovation. We've thought of the applications we can create with this platform. Here's some examples. We can detect skin problems, listen to the heart and lungs, inspect an injury, perform an ENT exam, a vision exam, supervise physical therapy using pose estimation, or perform an ultrasound. If my doctor had this attachment, I wouldn't have needed to go to the ER. We could have saved $7,000. The clearest ultrasound shown here cost $6,900, so it'd be paid off in just one visit. My doctor unfortunately caught COVID-19. With telemedicine, he wouldn't have been exposed and would still be able to treat other patients. This bed is really practical. Technology and AI is improving, and the need has never been higher. Medical costs are skyrocketing, and the need for isolating is great, and the number of elderly is growing rapidly. Any questions?
All right, thank you. Who would like to start with questions?
Me, I guess. Just one question. You were saying that your doctor will be able to do an ultrasound. It's going to be remotely. How the ultrasound usually require contact between the device that we do, or the ultrasound, and the patient. So maybe he can do temperature, but you do not have ultrasound at home for the patient to do that, do you?
Well, the robot, for the robotic arm, we can change tools for every job. So you could put an adapter on the end of the robotic arm, and it can do ultrasounds on the patient. And it can do other things like surgery, like we said, with haptic feedback. So a doctor, he could be controlling the robotic arm from anywhere. It could be across an ocean away, because the arm will be the one actually doing the surgery.
Okay, who's going to be helping the patient then? So if the patient laying in bed and the doctor, so you need a technician by its side anyway. So
Yeah.
just you are reducing one person time. Okay.
Yes, but then you're also able to get like specialists that maybe live across the world and wouldn't be able to travel to you. So it kind of like helps where you have like specific surgeries, or where you need like a very specific doctor who maybe can't necessarily fly from across the world for a procedure.
Like if you need to have a surgery right away and you can't fly for a couple hours to get to this designated place, then the doctor can just do it remotely, and he can do it very far away.
Okay, is your robotic arm, how do you sterilize it basically? Since if you're going to use it in something like this, it needs to be sterilized. Do you think about how it's going to be sterilized?
Well, we haven't necessarily thought like that far ahead, just because there's so much work that could still be done, right? Because this is something that we want to continue working on in the future, and that's something that we want to develop, making sure like the robotic arm movements are like smoother and that they're more easily controlled, dealing with like issues with connection, because if you're doing it from like a long distance, you need like a very strong connection. to be able to move the arm like with like the haptic feedback in real time. And I think once we like get a better idea of what the arm would look like in like a real life like application, we get a better idea of how we'd be able to sterilize it.
Good job, guys.
All right, time is up. Thank you very much.
So much.
Okay, next up. Concordia Lutheran School. And they'll be coming to us from Hong Kong.
Hi, sir. Hi, sir. Can you hear me?
Yes. Yeah, I think we're trying to bring you onto the panelist thing.
Yes. Can you see
You
my
can see
screen?
your screen, yes.
Oh,
Yeah, so yeah, just give me a second here. Okay, I think you may start whenever you're ready.
oh, thank you, sir. Oh, good morning, everyone. We are Team 2874. Well, nowadays, there are more than blind people in the city or other places around the world. So our invention make the problem. The problem we set to solve is that blind people cannot navigate around the city easily. Furthermore, there's a very long learning curve to navigate around the city. Currently, blind people require trials and errors to navigate through branches and crossroads located throughout the city. Our invention aims to help blind people adapt the environment for walking on the street and find their destination safely and easily.
The way it works is that a receiver will be installed at the tips of the blind person's sticks. Blind person's sticks detecting nearby beacons. The beacons will be located around on the street, on the floor. The person's phone will be connected to the sticks receivers and receive audio signal. The beacons located on the street will use to determine the location and proximity to the beacon. For example, a person walks near the traffic light and the receiver located at the tips of the stick will scan the nearby beacons. In this case, the tactile path located on the floor will act as a beacon. An audio signal will be sent to the client's headphone when a stick is in close proximity to the beacon. There are two parts in our invention. First part is the cane itself and the sensor inside on the roll. Our invention can provide several functions. iBeacon is a phone app after installing on a mobile device. The iBeacon can detect users' cane signal and detect the sensor on the roll. Let me show you about it. Sure. Demonstration. Just pretend this is the sensor located on the roll, and this is the tips of the stick. Here, tips of the stick. When the stick start running, it will detect all the beacons around the room or the floor. Okay, and when one beacon is in close proximity to the sensor, it will turn red. Okay, let me check it. Yeah. If I put our phone away from the device, it will stop alarming. And we can start navigation now. Okay, as you can see, if I put away my phone, the alarm stops. If I put my phone near it, it will turn. Yeah, and you can. I don't know if you can hear it, but
yes,
turn left. Can you hear that? Yeah, the turn left signal is determined by the destination set by the users. Yeah, it's just it's like a Google Map function. Yeah, it guides you to your destination and just overall easier to be used by blind people. Yeah, I think this is a relatively simple idea, but it's quite impactful because installed on a mass amount of sensors on the road, it can actually solve many problems for the blind people. You know.
Okay, time is up. All right, thank you. Okay, it's time for the Q&A.
I have a quick question. I wasn't sure if I heard that we need to have a sensor on the road for this device for it to work. If we need that, it's going to be like a lot of expenses to have these sensors on the road. So I'm not sure.
You know, there is a lot of sensors located on the road, but each traffic light will generally requires only one. Yeah, so it's not a big amount of sensors. Though it's not a big amount of sensors, so it is not a. So it is quite practical, you know. Yeah.
You go ahead.
So does this device also detect other pedestrians, like coming too close to you, to the person?
Yes, the Bluetooth actually scans other people's Bluetooth device as well, so it can actually manage to avoid them if needed. Okay, they can send instruction to the blind people headphones, you know, and tell them to turn left, turn right, or just stop. Yeah.
Okay. How about steps?
Steps, you can put a special sensors or at the start of the steps under it, and then the stick can pick up any signal theoretically. Yeah, you know, so it can tell the users to just walk up how many steps, you know, how many steps required.
Okay, thank you.
What kind of real world testing have you been able to do on this device?
The real world testing shows that this requires a huge learning curve, but we can get it to work. For example, when we navigate around our home, I put several sensors, not sensors but phone with Bluetooth connected, and we can navigate without looking at anything. Yeah, blindfolded, I mean. Yeah.
Okay, very good. Okay, I'm sorry. It looks like the time is up. But thank you very much for your presentation. Okay, next up is Nikte. I believe this is our last presentation. Okay, can you hear us?
Yes.
Okay, I think we're ready for you. You may begin whenever you're ready.
Yes. Hello, we are students of high school number 3 of the Autonomous University Hidalgo State. This robot is called Nikte. It's confirmed by
Ophid Angeles
and Naomi Alicia Sanchez Gutierrez. Okay. Due to currently health problems, we decided to innovate in this area, creating an assistance robot for people in isolation, which can perform task routine without the need for a professional. Among its function is food distribution using a motor's speak. This works with a set of wires that allows move 4 bands in parallel with a single motor. Distribution of pills is simulating a vending machine with capacity for 3 different pills and serum and water. The administration who can access the more function advanced of the robot. To know, the patient has predetermined profiles. Each patient has given an RFID card, and this specifies the medicine at mealtime as well, and generates a clinical history of the patient who can access of the database of the application.
It has two control options. One, connecting the application via Bluetooth. The Android application was developed in Java with Android Studio IDE, and the Windows application was developed in Python using the libraries Pserial, Tkinter, and Seculate3. Second form, NICTE was programmed as a line follower capable of identifying patterns on the floor for the activities of the robot. The structure consists in a metal structure for the base, MDF structure for the body and head, mechanical components, bands, gears, and electronical components, motors, and pumps.
The investment was made in the prototype series $22,716. The investment large scanning defects in the material, and in the future, it is source of contamination. Amount on the change recovery liquids 3 years ago, and maintains is so expensive, so it will even savings greetings. But we intend this project is open source so that anyone who can access the more function advances of the robot. For example, structure, circuit, and electrical devices.
By 2022, we implement a camera to visualize in real time the path of the robot. In this moment, the graphical user interface in process, and add a neural network based in your learning can make a better decision. For example, quantity and type of pills, and a voice case.
Okay, this robot is operated in restaurant and the combine the grandfather and grandmothers. In addition, we are monsters the NICTE robot operation. My partner is programmed the robot.
This is the Android application.
I take food.
Okay, I'm sorry, but the time is up. Yep, time is up. Okay, it's time for some questions and answers.
Yes.
Yeah, go ahead.
So I guess could you just help them a little bit? I think, what do I expect to see? Like when you pretend to be on that bed and the robot goes close to you, what do we expect to see? What's going to be measured?
Okay, in the pattern is reflect the for example, check vital signs. For example, when you put your hand in sensor, for example, the temperature and the pulse cardiac, it reflect this. It reflect. So, for example, when you put my hand, pulse, this is my pulse, and temperature is this. is reflected in the panel.
Okay, well, what are some of the potential actions depending on the pulse and the temperature?
Okay, when people and your patients enter is reflect, for example, the coronavirus is reflect is a symptom temperature, and this is reflect the temperature. And another than when people enter to the restaurant is the function when take temperature.
Okay, yeah, I'm sorry, we're out of time.
Can I ask a quick question?
Okay,
Sorry.
Sure. No, go ahead, doctor.
Just wondering, so you mentioned distribution of pills, if I understood well. I was wondering if your robot can remind me to take pills at a certain time during the day, how that works.
Yes, it provides medicines. Is imitate a vending machine with capacity for 3 different pills. My partner is activate the pills.
Okay.
And it provides the pill.
So is it going to dispense the number of pills I need to take? Can it be programmed to dispense pills at certain time during the day or?
Is the autonomous form with the jacket with the target with this, because in this case is the specify the medicine at mealtime as well, and when you put your is identified what medicine provides the patient.
Perfect. Thank you.
You're welcome.
Yes, thank you very much.
Thank you.
Yeah, thank you to everyone. This was wonderful.
Thank you.
Yeah, so lots of great projects today. I think these types of robotic competitions are possibly the most difficult because you start with basically a wide open slate, but then you have to eventually come down with a product. I'm looking forward to seeing some of these projects in the future, and then at that point I could say I saw it first at Robofest. So I encourage everyone to keep learning. In closing, I would like to introduce Dr. CJ Chung for some closing remarks.
Hello everyone, I am CJ Chung, Professor of Computer Science and the founder of Robofest. Thank you so much for your participation in today's RoboMed competition. All the projects were very creative and innovative. I'd like to thank all the coaches, teachers, mentors, parents, volunteers, and of course, students. In addition, we cannot give enough thanks to judges today. Dr. Teres Walker, thank you so much. Dr. Hao Jiang, thank you. Dr. Alexandra Kuzmanov, thank you. Dr. Yawen Lee, thank you so much. Mr. David Carvey, thank you. He was not able to attend today, but he was the code inspection judge. Also, I give kudos to Robofest staff. Mr. Elmo Santos, great job for coordinating this competition. Miss Sharon Pelonis, she did a great checking in teams today. Mr. Dan Oliver was the timer today. Thank you. At this time, on behalf of Robofest family, I would like to thank all the COVID-19 healthcare workers all around the world. You are the heroes. Our Robofest team are here actually to help you by creating better tools for you. They are the future heroes too. Let's give them a round of applause. I play this sound. See you on Saturday, October 17th at the closing and award ceremony. Thank you, everyone, and goodbye.